back to like third grade.
Yes.
So, yeah. The whole reason I have this on the front slide is because every single year, when we get to this section, it's supposed to be super fast because you guys are supposed to be really good at division. But basically, long division is pretty much not taught anymore. You probably haven't done it since second or third grade. Okay. Yeah. Yep. So I figured I'd have to kind of refresh you on this.
Yeah.
Yep. We definitely don't want the calculators today. Yeah, but they're going to be worthless. We're not going to be dividing numbers. That's because I have to remind you how to do long division. Yeah, we're doing long division with equations, not numbers. So you have to remember how to do it with numbers first. So first thing we look at is, since we're taking 2434 divided by 11. Now, generally you look at the first number, the 2, but in this case, the 11 is bigger than the 2, so it can't go into it. So then we move to the next number. And then we would say, how much, does 11 go into 24? You guys know it's twice. But in your head, you should be trying to figure, what would I multiply 11 by to make it fit this? Which is still 2. But you guys are just so used to numbers that in your head it's twice. So I'm going to multiply 11 by 2. I can't multiply by 3 because that would be bigger. So, and then I'm going to take 2 times 11, write it underneath, subtract. Do you guys remember what to do from here? Bring down the next number, yep. Yep, I know, like this should just be your test, right?
Yeah.
I think
Okay, so 11 into 23, actually in this case it's still the same. So I would multiply it by 2. 2 times 11, 22. 3 minus 2 is 1. Bring down the 4. Now, in the rare instance that this wasn't big enough, like maybe we were dividing by 18 or something, I would have to bring down the next number to be able to go into it. You bring down the numbers until it works. Kind of remember that? Okay. So 11 goes into 14. I'd multiply it by 1. So 1 times 11 is 11. We get 3. Okay, good. Yeah, so when you first learn division, you would just call it remainder 3. But we're not going to use remainder. So from this, here's how I'd write it. 2434 divided by 11 is 221 and 3 divided by 11. So like the remainder 3 was correct, but we write that in smarter terms now. So this is what we're doing with equations. And it definitely has a purpose. You just don't need to know the purpose yet. We have to learn division of it first. Somebody want me to go over the different parts of this long division? Okay. So we're actually going to end, because we're fitting in the whole section today, instead of splitting it up into 2, we're actually going to learn 2 different ways of dividing. One of them is exactly like this. It's called long division. The other way of division is called synthetic division, which you'll definitely like better, but it doesn't work for all of them. So we're going to learn the harder one first. Not harder, slower. Yeah, I know. It's definitely, it looks the same, but it's, it's sort of the same ideas. So because there's two terms out here, I'm going to look at the first two terms here. What you're dividing by out front kind of decides what you're going to divide by inside. Now, you definitely can't think to yourself, how many times does x plus 2 go into x squared plus 6x, because it just doesn't make sense. It doesn't really fit. So we're going to do like I was trying to lead into. What would I multiply x plus 2 by so that it kind of matches here? What you're going to do is only look at the leading terms. So the x is the hardest part to match up. What would I multiply x by so that it would match x squared? X. So I'm going to multiply by x on top. So underneath, what I'm going to write, I need to take x times x plus 2. X squared plus 2x. Now, when we have the 22 and the 11, we subtract them to find what's left over. So we're going to do the same. Just remember that you have to subtract the whole line. So I can only subtract like terms. 6x minus 2x, 4x. If we do these correct, this first term should always cancel out. X squared minus x squared would cancel. Are you okay with that a little bit so far? Obviously, it's going to feel weird for a little bit. What did we do next in division? Bring down the 8. So we're going to bring down plus 8. And then now I have to figure out how does x plus 2 go into 4x plus 8. So I'm going to focus on this x and focus on the 4x. What would I multiply x by to make it 4x? 4. So I multiply it by positive 4. And then I'm going to take 4 times x, 4 times 2. And in this case, I'm going to have 0 remainder because it would fit perfectly. So 8 minus 8, 4x, 4x, 4x. Now what this told us, x squared plus 6x plus 8 divided by, and I don't have to use that symbol, I could use a fraction bar too, divided by x plus 2 gave me exactly x plus 4. Now, if you want a preview of how this is going to be used, I could rearrange these things, and I could say x plus 4 times x plus 2 is x squared plus 6x plus 8. Like, this is a different way of factoring. And that's how you're going to use it in future classes. Because there's going to be a lot of times where you wouldn't know how to factor otherwise. Okay, but we don't need to know that yet. I was just kind of giving you a preview. Are we feeling okay on this problem? Questions on anything? What's up there? Should we just try another one to see if you're getting the steps down a little bit better? Okay. X squared minus 5x plus 4 divided by x minus 1. Now this one's going to divide perfectly as well. I didn't want to, I figured I'd start with the easier, more straightforward ones. Hi.
I need a packet, the unit 3 packet.
Oh,
Mr.
for
Stumpner's out.
He's out?
Yeah.
Uh-oh. How many? Mine's underneath that. How many packets are left? I don't think that's the last one, right?
That's, I think it's exactly.
Uh-oh. There's no orange sheets in between?
No, there is.
Oh, thank God. Okay, because I needed one more. Perfect.
Thank you.
Yep, I guess we didn't order many extras. What am I doing? I've got the roller. I numbered you guys now. I figure this should go to the new people. They haven't had a chance to roll yet. Although they might not even know what to roll with. You still have never gotten to roll? All right. Normally we roll to figure out who gets to roll. You never got to roll? Okay, who's going to help us first? 12. 12 is Henry. Wait, that's not right. Oh, it is. I numbered him weird. Oh, whatever.
Well, you can start by multiplying x minus 1 by x
Good. Where would I write the x?
on top.
Correct, but where? It actually will matter later.
Wait, care to elaborate on that?
Okay. So we've got the two terms here, and we were trying to divide into the two terms here.
Yeah, you read it on.
So you're going to write the x above at the end. Yep. It won't matter right now. It'll matter once we start having to like skip spots. I didn't expect you to know yet. I figured I'd just kind of ask.
I just didn't understand. No.
No, you're good. Okay, so good, x. So we need to multiply x by x to make x squared. Now I'm going to take x times x minus 1, which would be x squared minus 1x. If I want to write, you can write the 1 if you want. I'm going to subtract this line. If I did this correct, this should cancel. That does. Negative 5 minus negative 1 would be negative 4. Because it's like plus 1. Negative 5 plus 1. Yep, there's a lot of, it's going to be a lot of subtraction. Ooh, roll a whole bunch of times. They actually kind of stack up behind each other. No, that's the correct one. It just doesn't sit well. 28, 38?
38.
Oh yeah, that won't matter. That was next hour.
17.
17. Oh, and FYI, your numbers will change later because I screwed up numbering this one. What? I already forgot what you said.
17.
That was quick. So it's supposed to be Maddie, but I forgot to number Maddie on the chart. So it's sort of sit B. You guys can like rock, paper, scissors for all I care.
You bring down the 4.
Okay, good. Bring down the 4. Yeah, now what?
I don't know.
Oh, okay. That's all right. That's honest. Anybody help her out? What do I do once I bring down that 4? Yeah, rather than rolling anybody, I know this step is a little bit harder for now.
I'm trying to get the x into the negative 4.
Figure out what you have to multiply x by to make it negative 4x. So that would be negative 4. Okay, so negative 4 times x, negative 4 times negative 1. And when you subtract this line, there's an awful lot of different symbols, and so it's something you're going to have to keep clear. 4 minus 4 is nothing. Negative 4 minus negative 4 is nothing. So 0 remainder. Yeah,
So how did you get negative 4?
up on top.
Yeah.
So once you bring down that plus 4,
Yeah.
we were looking at negative 4x plus 4. And we need to figure out how does x minus 1 go into that? So what that means is, what would I multiply this by to make it this? So I'd multiply an x by a negative 4 to make it negative 4x.
Okay. Thank you.
It's going to take a little while to get the steps down because it's different than regular division. It's the same, but it's different. Which is super clear, I know, right? Same but different. Do you feel like you could try one on your own?
Yeah.
Why don't you see if you can do this one on your own?
Okay.
There. Oh, what the? Well, that's what you get for a cheap roller.
24.
24. Katie, you're 24. So I didn't know if you were ready or not, but I figured I would give you kind of a little advance notice if you wanted to ask people around you. You got this? Okay. Let's do the first step to make sure everybody did the first step right then. What do I do?
I did to get x to equal the same as 7x. I did 7x.
Yes.
Times
Yep.
x minus-
Okay, you said it a little bit wrong, but you
Yeah.
did it right. Yep, that's
Yeah.
okay. So we need to multiply by 7x to make x go into 7x squared. All right, so 7x times both of those would give me 7x squared minus 21x. Okay, let me erase those little lines. Okay, and then I need to subtract this. Okay. Negative 23 minus negative 21 is negative 23 plus 21, which is negative 2. Those cancel. Who'd you roll? Oh, I thought I heard you roll it. He's cautious. He doesn't want to like break it.
6.
6. Zena, you are 6. What would I do from here? Good. Okay. Now what? Do you want to keep going or do you want somebody else to go? Okay. I think it's because you're rolling so slow that it's falling up backwards.
30.
30. 30 is Grace.
Okay.
I'm not sure why, but once you would get to here, this is where it usually is kind of hard to remember the steps.
You have to see what multiplies
Yep.
by x minus 3 equal negative 2x plus 6.
Okay.
So negative 2.
Good. That's all I was really waiting for, but good. So multiply by negative 2. And I'm doing that so that this turns into negative 2x. So negative 2 times x, negative 2 times, oh, that's a bad line. Negative 2 times negative 3, which is actually exactly that again. Okay, well 6 minus 6, nothing. Negative 2 minus negative 2, nothing. So a remainder of 0. Just curious, how many people got 7x minus 2 on their own? Like, where are we at in this? Okay, so I'll definitely go to a harder one then. I didn't know if we should keep working on some like this. Let's go to a harder one. Sure, that works. Oh God, you guys act like this is like,
Different than last.
you act like this is a whole different league. Yeah.
Oh, it's a different pot.
Or is it gonna be like the easier one?
Well, no, because the easier ones can be done a different way. Long division is generally saved for the hard ones. There's a different method we're going to learn for the easy ones that goes even quicker. So that's why you'll get one like this. Do you want me to help you start? Because it looks like a lot of you are staring at that like this is, you're staring at like I gave you a different, like we moved to a different class. Yes?
Can you just rewrite it or something? Like, x plus 4 outside and rewrite the first part and inside.
Hmm? That's what division is, like the first thing divided by the second thing. Okay, now the part that I didn't expect you to just flat out notice right away is there are missing terms. Well, like, because it goes fourth power, second power. So there are missing powers. When we're doing long division, you generally want to put in the missing ones so that things line up. So y to the fourth plus 0, y cubed, plus 9y squared, plus 0y, plus 20. Well, clearly I went to like just the most difficult thing we're going to get. It's okay. We're smart. Y squared plus 0y plus 4. Now, I actually did this on purpose. I did this on purpose because for some people it's easier to see how to do long division with the harder ones. The easier ones, you kind of tend to memorize steps when that doesn't help. I'm still starting the same way. What am I going to multiply y squared by to turn it into y to the fourth? Y squared. Now I'm going to write it above the third term because I've got three things out front. And I do that because that's kind of where it's going to match up. Okay, so y squared times all three. So that's going to be y to the fourth plus 0y cubed, so that won't work, plus 4y squared. So I'm going to subtract that whole thing. Okay. Let me erase those lines so I don't throw you off. Now, are you guys okay with what I wrote? Did I like jump too far? The starting point is the same as what we did before. Okay, so cancel, still nothing, 0 minus 0. 9 minus 4 is 5y squared. Okay, good. Yes?
So I did that, I just didn't add the extra term.
I know. I picked this one because it'll work if you don't.
Will it always work if you don't?
What?
Will it always work if you don't?
Definitely not. This one works because they're all even powers only, so things line up. If the powers were off in any which way, it screws up, so you have to put in the zeros like I did. So I'm just showing everybody how to do the missing terms if you need it. So I'd bring down the next term, which doesn't help because I've got three terms out front and I need to match up with three terms. So I'm immediately going to have to bring down the plus 20 as well. I basically bring down until the terms line up. Is it that bad? She was sighing over here. Oh, we should roll. Elizabeth. Elizabeth, what would I do from here? Perfect. So I want to know what to multiply y squared to make it 5y squared. And it'd be plus 5. And I'm going to write it kind of at the term I'm kind of currently on. Okay, so now I'm going to take the plus 5 times all the things, and I would get 5y squared plus 0y plus 20. I should have picked some that didn't work out perfect.
Would it?
Go for it.
Oh, wait, never mind.
Okay. Cancel, cancel, cancel.
Perfect.
So your answer that you would give is y squared plus 5. That is generally as difficult as you'll run into because we had a lot of terms.
So if you had like a remainder of like 2, you just put like 2 over y squared plus
Yes.
1.
I can't remember if you run into remainders or not yet. If you have a remainder, let's say your remainder is 5x, I don't know. I guess that'd be stupid because these are y's, but whatever. Whatever your remainder is, you write that over what you divided by. If you had a remainder.
Yeah.
But I can't remember if you're going to get one or not. I think they try to have them work out perfectly for a while so that you're used to division. I think this is the last example. Even if it isn't, maybe we should just stop there and try the other method because it's already 5 after. Are you feeling okay on long division?
Yeah.
I guess that's the main thing. Okay. Right there. Synthetic division. Sounds so much worse. Synthetic. It's like fake division. But everybody loves it because it's not actually dividing. It's multiplying. I mean, I say that like it's shocking, but we literally just did multiplication to do long division anyway. We figured out what to multiply by each time. Do you remember when we did factors and we had factors and zeros or solutions? So x plus 2 is called a factor. Whoa, what the heck happened there? X plus 2 would be called a factor. Do you remember what the zero or solution would be for x plus 2? -2. Because you would set it equal to 0, like you would subtract 2 from both sides. This was like the solution, this was the factor. So when we had that test on factoring, you would do the factoring, and then your answer was basically the opposite all the time. Yes? Semi, remember that? Okay. It matters because synthetic division, you have to divide by the 0 and not the factor. So here's how we're going to do this, and it's probably easiest if I just show you and then explain it to you. X squared plus 6x plus 8, we will write down as 168. And we're going to divide by -2. Yeah, it's easier if I just show you first. You probably want to wait until we're done to write it down.
Okay.
The way that I'm going to do division with this setup, I'm going to bring the first number down. I'm going to multiply -2 and 1 to get that answer. I'm going to add them.
Oh,
I'm going to multiply them. I'm going to add them. And my answer is going to be 1x plus 4, remainder 0. Yeah, this looks like a total different language. I'm still shocked and amazed how somebody came up with this process on their own.
What it is.
But it's actually pretty ingenious the way it works. So what you're going to do is if you're trying to divide 1x squared plus 6x plus 8, you're just going to write down the numbers, nothing with the letters. So 1x squared plus 6x plus 8. Yeah.
What happened to the other x?
You mean the x plus 2?
Since 6x, you removed the x,
Yep.
do you not put it back down to 4?
When we did the long division, so if I would have done x squared plus 6x plus 8 long division, and divided by x plus 2, my answer would have been x plus 4. I think we actually did this one. So the answer was basically lower powered. That's what happens here. That's the easiest way to say it.
And the negative 2 you got it from the.
X plus 2. Yes. It's always the opposite. Yes.
So what did you multiply?
Well, I was trying to explain it again. Just
Oh.
let's pause on the questions because I do know it's super weird. Okay. So 1x squared plus 6x plus 8. We're dividing by, that's what this little weird backwards box is, dividing by x plus 2. Now, the way that you divide by x plus 2 as a factor is you divide by its 0. So that's why I put negative 2 in the box instead of x plus 2. And division is just a lot of what do you multiply by and subtract, things like that. So that's actually what this is. So you bring down the first term, which is a 1. Multiply negative 2 times 1, and you get negative 2. And then you're going to add down, kind of like what I did over here, 1 and 0. 6 and negative 2 is 4. I'm going to take that answer times the box and get negative 8. Add down, I get 0. This is my remainder. And everything in this lower left-hand corner is your answer. So the one right next to the bar is the number. The one next to the number is the x. The one next to that would be the x squared. The one next to that would be the x cubed. But we didn't have those, so they're not in the answer. So that's how you read the answer, is you kind of read it backwards. However many things the answer is tells you what the letters are.
If the remainder wasn't 0, would you include it in your answer?
Yes, but we haven't had that yet. The other thing I want to say ahead of time, maybe I have this on a different slide, but I don't think so. Synthetic division is only for linear factors. Like x plus 4, x minus 6. So remember, we just did long division. We divided by x squared plus, x squared plus 3 or something. That's a quadratic. So we couldn't do synthetic division. We can only do synthetic division if we can write this as a single number in the box. So synthetic division only works on the simpler ones, but it is a much faster way of doing the simpler ones. Long division needs to be used when they're more complicated. Yes, okay. Oh, all right. Other questions on this dark magic that we just did? Okay, let's try another one together. I'm going to skip that one. Go right to that one. We're dividing x cubed minus 1 by x minus 1. Now, I know you don't remember these off the top of your head, but this is a difference of cubes, which can be factored evenly. If you remember it, fantastic.
Would you fill in the 0?
Yes. Yeah, I was just going to wait till everybody got it written down. So filling in the numbers for synthetic division, we have 1x cubed, 0x squared, 0x minus 1. Missing terms matter.
Wait, what?
1x cubed plus 0x squared plus 0x minus 1. But you only fill in the numbers. You don't actually write the terms. The original thing that we were asked to divide was missing 2 of them. What number do I put in this little backwards box? Positive 1. So the 0 from x minus 1 is positive 1. Okay. So I write a line underneath like I'm doing addition or something. And then I'm going to put a vertical bar before the last number. I'm always going to write it with this last number over it. Okay. We're going to add the numbers down, multiply diagonal. So 1 and nothing is 1. 1 times 1 is 1. This is going to be a lot of 1s. 0 plus 1 is 1. 1 times 1, this is way too many 1s. 0 plus 1 is 1. 1 times 1 is 1. Negative 1 plus 1, 0. So we have a remainder of 0. Yeah, I know, this doesn't feel like math. It feels weird. It's kind of fun though, because it's different. So our answer is plus 1 plus 1x. A lot of people like to write these backwards so that they can figure out the letters. Plus 1x squared.
Could you just write that as like x squared plus x plus 1?
Definitely. So the original question, divide x cubed minus 1 by x minus 1. The answer is x squared plus x plus 1. Now the weird part to me is it seems like you guys did better on long division. Like that seemed like it made a lot more sense.
Yeah.
I get that this doesn't make sense, but this is easier to do. Once you get the steps right, obviously. Now, is there certain parts of this you're having trouble doing or understanding, or I don't know what to say? Yes.
Can you like go slower on when we like add and like multiply the lines and stuff? Like can you just like re-explain that?
Go slower on addition.
No, like when you're
How I was writing the numbers where.
yeah.
Okay.
I'm just kind of confused like when you write the arrows, you know.
Yep.
I'm just kind of confused which ones were like multiplying.
Yeah.
Saying.
You're always going to add down, multiply up. So 1 and nothing is 1. I'm going to multiply by the box. So 1 times 1 is 1. Add down, I get 1. This one's weird because they're all 1s. I'm going to multiply times the box. So 1 times 1 is 1. Add down, get 1. Times the box, get 1. Negative 1 plus 1 is 0. So you're actually going to follow the same pattern repeatedly. Add them, multiply by the box, right into the next spot. Add them.
Yeah.
Once you get the process, it is easy. Once you get it, it's just weird. Here, this is one you would never try by hand.
Never will.
But with synthetic division, it should be easy.
Okay.
Do you guys need help setting it up, or do you think you can set it up and do it?
Can we just open it by ourselves?
Why don't I give you a minute where you can do it by yourself, and if you need help, well, then we'll just do it together in about a minute. FYI, it's being recorded. the microphone's right here, so. Just thought I'd give you a little warning there. I could care less, but I figure you may want to know. Okay, if you set it up correct, you should have 1, -2, 3, 1. Oh God, I forgot a missing one.
Yeah, isn't it, X4?
Yep, pretend I didn't write that.
3,
Pretend I didn't write it. Yep, didn't happen.
2.
Yes. And it absolutely screws up the answer if you forget to write the zeros.
I don't get what I zero.
There's no x squared term.
Oh, okay.
Now, obviously, I picked this one on purpose because of that stuff. Just, you got to keep an eye out for it. Okay, so then 1 and nothing is 1 times the box. 3. -2 and 3 is, well, 1 again. Too many ones. Times 3 is 3. There we go. Now we got some note. 3 times 3 is 9. 12. 36. 37. So this one worked out terribly. But we still got our answer, so that's really all we cared about. Now, in the future, the whole point of using synthetic division is you want to find a remainder of 0. So in the future, we would just say that dividing by x minus 3 didn't work. It's not a root, it's not a factor. But for right now you're just asked to find the answer. So I would say the answer is, let's see, we've got 12, we've got 3x, we've got 1x squared, we've got 1x cubed. That's my answer with a remainder of 37. Okay, so then we have x cubed plus x squared plus 3x plus a lot of pluses. And then instead of writing remainder 37, I've got 37 of the x minus 3's left over. Now this last one I put up here is as difficult as you're going to run into for this. So I wanted to make sure in our notes that we had difficult problems for you to try, look at. The ones you're going to get in homework aren't this hard. I'm purposely trying to give harder ones so that you could see all the different things that could happen. I don't know. Is there parts of this you want me to explain? Like, is there parts of this that just aren't clicking, like totally not making sense?
Or like when you need to fill in for spots, just like what always needs to be there? Like does there always need to be in, that's kind of what I'm confused about.
Like, always need to be a 0 type thing, or?
Yeah, like how do you know when you need to put?
Well, so I'm purposely putting these numbers in order, right? Like, I make sure to follow the order that they were written in standard form. And if I have an order to them, a missing term would screw up the order, I guess. So, like this 3 on the corner, that'll never matter because that couldn't have a missing term, like we wouldn't use it. There may be missing terms on the answer down below, like there might be zeros. I guess it's just gonna always have to be this one for your question. This top set of numbers would always have to have missing terms if there were any. And it's not even that common that that happens. I just wanted to make sure it was in the notes. Yeah.
I just still don't get the multiplying that
Like the order.
Like how you, I don't know. I get everything else.
Add, multiply, add, multiply, add. I don't know. You just alternate every time. So I start by adding. Yeah, I know. It sounds easy, but like until it makes sense, it's not, right? Like once you can see the pattern, then it feels easy. If you can't see the pattern, it looks like I'm just writing random things. So you're always going to start by addition. So whatever this first number is just goes down. So plus nothing, that's blank. Whatever this answer is will be multiplied times the box. So that's when I say you alternate by add, multiply. When you do the addition, the answer to the addition will be multiplied by the box. So in this case, 1 times 3, and then I write my answer in the next spot. So the 1 times the 3 was the 3. I was hoping these arrows weren't making it more complicated. The arrows I'm just drawing there to show you where the next thing would be written. And then as soon as I have two numbers there, I add them again. So -2 plus 3 was 1. I take that answer times the box, and I write it in the next spot. Once you get the habit or pattern down of adding, multiplying, it never changes at least. It's always just going to be that order, doing those exact same things. The numbers would always change, but it's always going to be that same pattern at least. Part of it might just be practice. I know it's annoying, but I don't know. That's pretty much the whole hour, I suppose. I think we're done at 29. Yeah. Ouch. You okay? Okay. Okay, I'll stop there.